are in listen-only mode.
Hello, my name is Brittany Kapinski and I want to welcome everyone. It is now 1 p.m., so we will begin our presentation shortly. Today on Friday, February 10th, we will have our presentation on Planning for Innovation in Waste Management and Recycling, given by Andrew Dane and John Caters. For help during today's webcast, please feel free to type your questions in the chat box found in the webinar toolbar to the right of your screen or call 1-800-263-6317. For content questions, please feel free to type those in the questions box and we'll be able to answer those at the end of the presentation during the question and answer session. Here's a list of the sponsoring chapters, divisions, and universities. I would like to thank all of the participating chapters, divisions, and universities for making these webcasts possible. As you can see, we have quite a few webcasts coming up in the next few months. To register for these upcoming webcasts, please visit www.utah-apa.org/webcast and register for your webcast of choice. We are now offering a distance education webcast to help you get your ethics or law credits. These webcasts are available to view at www.utah-apa.org/webcast-archive. And you can also follow us on Twitter at Planning Webcast or like us on Facebook, Planning Webcast Series, to receive up-to-date information on the Planning Webcast Series sponsored by chapters, divisions, and universities. To log your CM credits for attending today's webcast, please go to www.planning.org/CM, select today's date, which is Friday, February 10th, and then select today's webcast, Planning for Innovation in Waste Management and Recycling. This webcast is available for 1.5 CM credits. We are also recording today's webcast, and it will be available along with a 6-slide per page PDF of the presentation at www.utah-apa.org/webcast-archive. At this time, I would like to introduce our speakers for today, Andrew Dane and John Caters. Andrew Dane has over 14 years of planning and community development experience. He has helped dozens of clients with a variety of grant writing, economic, and rural development projects, successfully securing over $100 million in grants, loans, and tax incentives through HUD, USDA, DOE, and other programs. He has provided planning and feasibility assistance for farms, industry, tribes, local governments, and utilities seeking to deploy bioenergy technologies. A Wisconsin native, his graduate degree is in urban and regional planning from Arizona. He is a member of the American Planning Association, currently helping draft the APA's Energy Policy Guide. He also serves on the Education and Training Committee for the Institute for Sustainable Infrastructure. Dr. John Caters, Associate Professor of Natural and Applied Sciences and Engineering at the University of Wisconsin-Green Bay, holds a doctorate in Civil and Environmental Engineering from Marquette University, a Master of Science in Environmental Science and Policy, and a Bachelor of Science in Environmental Science and Business Management from the University of Wisconsin-Green Bay. Dr. Caters has a broad background in waste management, recycling, renewable energy, and wastewater treatment, and also co-directs the university's Environmental Management and Business Institute. He has conducted extensive research and consulted with a wide variety of clients on anaerobic digestion and the development of markets for recycled products and materials. In addition, he works as a project design leader for Short Elliott Hendrickson Inc. and assists in the development of new products made from waste materials at NCAP Inc. in Green Bay, Wisconsin. Caters has received numerous awards, including the UW Green Bay Founders Award for Community Outreach. He was named a Wisconsin Idea Fellow by the University of Wisconsin System in recognition of his outstanding public service and outreach to business and industry, and was cited as one of the 50 people you should know in Brown County by the Green Bay Area Chamber of Commerce. Let's welcome Andrew and John.
Thank you. This is John Caters. I'm going to kick off the presentation today. And essentially what we're going to do is I'm going to provide a fairly high-level overview with some local examples from Brown County and from Wisconsin in terms of how some of these things can be implemented. And then Andrew Dane will follow that up and talk about this more from a planning perspective. So with that, I'll go to the next slide. And you just heard a little bit about my background, but I think it would be good just to touch base on a couple of these different things. One thing is I do work at the University of Wisconsin-Green Bay as a faculty member in a department called Natural and Applied Sciences, which is set up a little bit differently than most other academic departments across the country. Within our department, we have geoscientists, chemists, physicists, mathematicians, engineers, and we do a lot of collaborative projects. And I think waste management, recycling, renewable energy lend itself very well to having a department set up like that. I also do co-direct our Environmental Management and Business Institute. The other co-director is actually an environmental economist, and again, I think there's some really good linkages in terms of how all these different things fit together. You did hear a little bit about some of my experience, so I will skip over a little bit of that, but would also say that I do chair the Brown County Solid Waste Board, so I'm actively involved in a lot of decisions that are being made at the local level, both in terms of recycling, landfilling, and solid waste management in general. Some of the previous experience that I've had, which is interesting to this topic as well, is that I did serve as a commodity specialist for what was called the Wisconsin Recycling Market Development Board at the time. And in that role, I was basically given a budget to focus on creating new businesses around recycling and solid waste, and also helping existing businesses expand by creating new product lines using a range of different solid waste, a range of different recyclable materials. At that point in time, we were focusing on things like computer electronics that were, not at the forefront of recycling at that particular time, but have certainly emerged since that point in time, and have had a lot of efforts put behind recycling those, keeping them out of the landfill, and beneficially reusing those things. I also had some extensive experience working with business and industry on waste minimization and pollution prevention assessments, and again, through that process there's a lot of common opportunities that we see, whether it's a business or an industry or within a community as well. And going back even a little bit further, my master's thesis was on the economics of recycling in Wisconsin, which was done right when the recycling law was kicking off. So with that background, what I would like to talk about is essentially a summary of the opportunity as I see it here today. And I've got the term waste on this first slide, and I really do not like that term waste. I think a much better way to describe these things is really a resource that's out of place and is not being utilized as effectively as it could potentially be. And the other thing I would say is that in this day and age, we're starting to really see the terms waste and energy be used interchangeably, and one of the things that we can do is try and extract as much energy as possible out of these resources that we have available to us. And I'll talk about some examples of that in a little bit. So I guess the other moral to the story is that recycling is really a very small component of the overall waste management system or resource management system that we have in place. In saying that, as we work in our local communities, there's a number of different folks that are generating these different types of resources or misplacing these resources, as the case may be. Some of it could be municipal type resources, some of it could be industrial, and some of it could be agricultural. And as I see this, the opportunity from a planning perspective is to really look at our communities in general and see that there are some opportunities by kind of thinking outside some of these normal areas that we kind of separate and isolate sometimes. Within Wisconsin itself, there's been some opportunities to create new jobs, create new opportunities, and one of the things that has happened is our recycling or our solid waste tipping fees have increased. And in some regard, that was due to the fact that there was a lot of out-of-state waste that was coming to Wisconsin, and that this kind of became an economic issue. So the increased tipping fee creates an opportunity. The other thing that creates an opportunity is obviously the increase in energy costs that we've seen, and those kind of fluctuate and go up and down. But anytime you're hauling this stuff greater distances, that creates more opportunities for entrepreneurial type people to get involved and I think come up with things that are more strategic and ultimately more efficient in terms of dealing with these materials. So along those lines, from a planning perspective, then one of the easiest things to do is try and identify all of these different materials that might be located within your particular community. And one of the terms that we use a lot is watersheds, but I think we forget about the fact that there are also waste sheds out there. And some of these things can be used very synergistically, and in terms of the aggregation of waste, a lot of times it might not make economic sense for one particular party to do something, but if I can aggregate these wastes and create some economies of scale, then the overall opportunities just increase and create more opportunities essentially. So the next thing I would like to get us to focus on a little bit is the waste management hierarchy. And this is a hierarchy that was actually codified in the state of Wisconsin, and this is essentially a priority list in terms of how we should be managing the resources that are out there. And essentially for my portion of the presentation, what I want to do is walk us down this waste management hierarchy and provide some examples of some projects that have been done in our region in a number of these different areas. Again, I think we get hung up on recycling, and as we think about recycling, that's really our third best choice or our third best option in terms of how to manage these materials. So the first thing we ultimately want to do is look at reduction. And some people have, coined this phrase zero waste and that sort of thing. And as I think about zero waste, I tend to think about it from an ecosystems perspective, where there really is not a lot of waste out in nature. And if we can get these materials cycling and get them reused and keep them cycling, that's the way to reduce the amount of resources that need to be extracted from the earth. So I would describe it as we don't have enough decomposers in the industrial manufacturing system, and that's the reason we ultimately end up with piles of stuff that at some point need to go somewhere. Across the country, there have been a number of communities that have done a very good job in terms of trying to achieve zero waste. San Francisco is always one that you see in the literature, where they're up to about 77% diversion, doing really well, recycling organics, doing a number of things that we'll hear about in a bit. Reuse would be the next option, and I'll give you some examples on that. Recycling I'll spend a bit more time on because that's one that a lot of people are interested in these days, particularly as state budgets start to shrink and so on. And then we'll get into composting, energy recovery, and ultimately landfills as well. So we'll kind of work through the presentation in that fashion. So as I look at reduction, this really becomes, in many ways, an educational type endeavor. And it's getting the general public to understand that these are important things, and as they're out at the grocery store purchasing materials, they should be looking at it from that perspective. I kind of take a bigger picture, having spent a lot of time working with business and industry, thinking about what goes on in terms of the raw materials that are being sourced for the products that are being produced by those manufacturing facilities. And as we look at some of the environmental legacies that are out there, the idea that we should select non-toxic raw materials to make products becomes an important one. We're dealing with about a $1 billion cleanup in the local watershed here in the Fox River for PCBs associated with paper recycling. Again, if there had been a different decision made at that point in time in terms of raw material selection, maybe we wouldn't have that problem. Again, we'd ultimately like to come up with raw materials that are renewable, come up with raw materials that are abundant, and again, as energy prices will have a tendency to increase, it would be good to try and source as many of these raw materials from locally available places as possible. Ultimately, there may be process changes required to do that, and as companies start thinking about environmental legacy, green, that sort of thing, this all boils down to producer responsibility in one way, but I always like to think of it in terms of process efficiency, and again, getting closer to that ability to mimic what nature does out there. One of my colleagues actually did his doctoral work on eco-industrial systems, and there were a number of them that were promoted across the United States, and he basically went to each of those different locations to see what was actually there, and when he arrived he really did not find very much. So we haven't really taken advantage of industrial ecology and these symbiotic relationships that might be able to exist between different businesses and industries. The second example here for reuse is a local example. It's a company called Tosca, and for those of you not in Wisconsin, which is most of you, this is the perfect Wisconsin company because they refurbish beer barrels and they also manufacture cheese boxes for the cheese industry. I've got a little web link here. This company was actually featured on the History Channel for some of the work that they do in refurbishing beer barrels. And again, they do most of the work for the major brewers in the United States. A lot of the beer barrels have dents in them. They need to fix the chimes, those sorts of things. But it essentially allows that product to be reused for a very, very long period of time. On the cheese box side, through the Environmental Management and Business Institute, we had an opportunity to have an intern essentially work with these guys, looking at their wooden-based cheese box versus plastic cheese boxes that they would be competing with in the marketplace, to determine which one of those might have a lower environmental impact. And some of that's being driven by companies like Walmart that are asking their suppliers and asking the companies that they work with to document all that sort of stuff. And again, I think this is a great opportunity for planners to start looking at some of the things I talked about on the previous slide in terms of sourcing local resources, those sorts of things. That's certainly going to reduce the overall life cycle impacts of the products that are manufactured. So pretty interesting company, been around for a long time, and they're looking at expanding and growing based on their ability to keep these products circulating as we talked about earlier. In terms of recycling, the state of Wisconsin was one of the first states to really have a very aggressive recycling law, and this law was essentially implemented in the early 1990s, and it was phased in over about a 4-year period. And the key features of the recycling program here was essentially a landfill and incinerator ban on a list of materials, which was the more conventional recyclables that we would think about in terms of cans, bottles, newspapers, those types of things. The way the system was set up in Wisconsin to fund this process was that each community had the opportunity to become what was called a responsible unit. And in the original process, the thought was that there would be 72 responsible units in Wisconsin, which would be one for each county. If you know anything about Wisconsin government, didn't quite work that way. People are very strong in terms of local control. And because of that, we ultimately ended up with around 1,200 responsible units, which begs the question in terms of, what is the overall efficiency of the system when you've got that many different people in charge of recycling and so on. And that's ultimately what led to the selection of my topic for my master's thesis in terms of whether or not this was an efficient process. Several years after that, the DNR started issuing grants to what they called effective recycling programs. And some of the things that they talked about there were the need to consolidate some of these responsible units and trying to achieve some economies of scale and so on. So again, that's really a planning situation to try and get people to work together, and Andrew will touch on that a little bit in the second half of the presentation. At the bottom of the slide, I've got a picture of the recycling symbol. And I think one of the things we need to remember with that recycling symbol is it's really got 3 major components to it. Collection and processing is really only the first component of recycling. We do need to have viable businesses available that can provide remanufacturing and repurposing of those materials so that we can get them back to the consumer. So if any one of those 3 areas falls apart, the whole system falls apart. And again, I think given future resource constraints on energy and that sort of thing, it would be best if we could plan to do as much of this locally as we possibly can. Benefits of recycling, most of us are probably pretty familiar with that. Obviously, the conservation of natural resources is a big one, and that varies depending on the recycling material that you're talking about. In the markets, aluminum obviously commands a fairly large price, and that price is really essentially to offset the electricity that is saved through the recycling. So really those things, again, waste and energy are essentially one and the same. Another big issue that we hear about these days is greenhouse gas emissions. Of course, if you can document the energy savings, you can tie that back to greenhouse gas emissions. Again, these are some of the things that a lot of major companies are looking for, and again, documenting that locally is a good thing. There have been litter, illegal dumping issues, all that sort of thing, so just awareness of recycling programs I think helps that as well. And based on my experience, I think I can really point to the fact that if you do this correctly, there can be some good opportunities to create local jobs, local businesses, and that in that framework. And I would point to a couple in the state of Wisconsin. One is a computer and electronics company that I actually helped get funding for back in the late 90s. They're now one of the leaders, certainly in the state of Wisconsin, but also in the upper Midwest in terms of doing that. And one of the companies that I actually work for, NCAP, was also funded during my time with the Recycling Market Development Board. And they're taking a fairly non-traditional material, paper mill sludge, paper mill solids, and recycling that into lawn and garden type products. And they've been a very successful company. All of that stuff is going to help us avoid landfill expansions and keep this material, again, circulating in the economic system and creating value. There was a study done, waste characterization essentially, of the materials going into landfills in the state of Wisconsin. And on this slide you can see the average price per ton from December of 2009 and the tons that were estimated to be thrown in Wisconsin landfills based on the waste characterization study. And if we just do some simple math and take the value of those materials times the tons that were landfilled, you can see that the market value of the stuff that we threw away by not properly recycling amounted to more than $50 million. Okay, of course there's going to be some cost with collection and processing of that material, but that's a lot of money to be throwing in a landfill because we don't do the education and because we don't do proper recycling. Don't take it as serious as maybe what some other places do. So again, I think this kind of highlights the opportunity that's out there. As we look at funding for recycling in Wisconsin, and this is probably an issue all over the country, initially the state provided grants of about 30 to 40% of the operating costs for the responsible units. And during the last budget cycle, again with the economy on the downturn and funding issues and that sort of thing, they were essentially looking to eliminate all of the funding for recycling operations in the state. And the recycling community stood up fairly aggressively and said, you know, this is a good thing, it creates jobs, that sort of thing. And the funding was essentially restored, at least on a temporary basis. So we'll see how that plays out going forward. Looking back historically, I've got some programs there from the Recycling Market Development Board that were available to businesses and communities across the state to help them with early planning grants for business development, new product ideas, those sorts of things, low interest loans, demonstration grants available through the DNR. And there were also some research grants to try and link collaborators from the university with folks in the general programs no longer exist and have been eliminated. So if we're looking at strategic investments, it's now going to be up to the entrepreneur in many ways to create the opportunities, invest the capital to take these projects forward, which is really a change in the way things were before. I mentioned economies of scale and trying to get responsible units to work together, and this is some Wisconsin data from 2009 that looks at the responsible units by population on the left side and measures it in terms of three pretty critical parameters. One is the average pounds of recyclables collected per person. The second one is the average dollars spent per person by the responsible units. And the third one deals with the average dollars per ton that's achieved from collecting these materials. And again, if we start looking at this with the red bars in particular, the average dollars spent per person, we can see that that number does get smaller as the number of people gets larger, which points us towards those economies of scale. It's a little bit different. There's kind of a sweet spot in that 10 to 25,000 range in terms of average dollars per ton. So actually the lower costs are at the really big and then somewhere between that 10 and 25,000. So from a planning perspective, you know, do we try and arrange our responsible units to fit into those types of categories, and can we achieve some savings by looking at just what the right size cooperative agreements would be for those types of things? So the data is good. As we look at some other emerging trends in recycling, single stream is one thing that is becoming more popular, and that's essentially where you throw everything into the same bin. Studies have shown that that does greatly increase the recycling rate. It can reduce costs. Initially there were concerns from some of the end users of the recycling materials about quality, those types of things. I think most of those have been alleviated based on having a number of single stream material recovery facilities across the country doing a very good job. And I'll show you an example of that in northeast Wisconsin in a second. A couple other things would be going beyond this blue bin and essentially trying to work together in an integrated approach to look at trash and recycling and how we can make these things work together. Again, some of the sorting that's available, how do we quantify these resources, becomes really important. And from a financial standpoint, there's been people that have obviously implemented what's called pay-as-you-throw, where the more garbage you have, the greater the cost for disposing of that garbage. Another term for that would be volume-based fees. So again, I think there's a number of different ways where people are thinking outside the box and how we manage all these different materials, and these things will become more common as everybody's looking to achieve more efficiencies. The other key thing I see going forward is the need for intergovernmental or intergovernment cooperation, where by working together you can achieve some savings through joint contracting, joint offering of services, joint outreach in terms of education, those sorts of things. And in order to do that, you really need to have some strong political leaders, and you need to develop some very strong local agreements to make sure that everybody is essentially protected, because the worst thing you want to have is garbage starting to pile up, and we've seen some examples of that globally when garbage workers have went on strike in Italy and so on. So that's not a good scenario. So you need to make sure that everybody can work together and we have a reliable system in place. A couple other opportunities that are out there, and these would, again, kind of fall under this non-traditional recyclable category. One is construction and demolition debris. And we've seen a huge increase in not only the amount of this material that's being recycled, but some of the creativity in the ways that these materials can be used. So this can prolong a landfill pretty substantially, because these materials do typically make up a fairly high percentage of the materials that go to landfill. Again, some of the top materials would typically be shingles, which could be recycled back into asphalt, could be used for a number of different things. Untreated wood, again, if I can take that untreated wood and turn it into, a landscape type product, or I can turn it into a energy product a little bit further down the hierarchy, there's plenty of opportunities there. Same thing with concrete, brick, that sort of thing, turning them back into aggregate and so on. And the other big opportunity is really organics recycling, and Andrew's going to spend a fair amount of time talking about this, so I don't want to take all his thunder, but there are some real opportunities there as well. And those could be both for organic type products, or it could be for energy recovery as well. This is one example here of a composting project that was done in the city of Appleton, and this one was a little bit out of the ordinary in the fact that they were taking biosolids generated at the local wastewater treatment plant and combining those with yard waste that was collected in the community. In this case, they were using some of that material to cap a landfill, but the opportunity does exist to turn this into value-added products that can be sold in the marketplace. And again, I would throw out NCAP as an example. They're taking Milorganite from the city of Milwaukee, blending it in with some of the paper mill residuals, and producing products that are sold, commercially and also in the professional markets. So on the left, you can kind of see a picture of the greater composting pad. There's a stormwater collection basin that you see on the right side of that picture, and the picture on the right basically represents some of the windrows. And the composting contractor that worked on this project is also doing a lot of food waste composting for some of the larger big box stores in Wisconsin as well. This brings us to landfills, and again, at some point, there's still going to be a need for landfills no matter what we do on most of this other stuff. So having a good strategic landfill system in place is actually a very good thing. And there's really been a trend away from publicly owned landfills to more privately owned landfills. And in Wisconsin, there's just a handful of publicly owned landfills that exist at this point in time. Most of the big players on the private side have come in and taken up a lot of that business. But what does happen in that scenario is that landfills get larger. And we can look at that a couple different ways. One way is, that there's NIMBY associated with trying to site these facilities. But the other thing we see is that there's greater opportunities for energy recovery to take advantage of the anaerobic digestion process that actually occurs in these landfills. So that's potentially a good thing to produce some green power. One of the potential issues that I kind of grapple with as the chair of County Solid Waste Board is the fact that if we lose the municipal landfills, we might also lose some of the other services that go along with the municipal landfill. And that could include some of the educational activities that go on. It also could include some other ancillary services like household hazardous waste facilities, which are keeping that material out of the landfill. You're keeping that material out of the wastewater treatment plants. And again, a lot of that is funded through a small diversion from the landfill tipping fee. So again, thinking more broadly from a community standpoint, if you lose the landfill, you're probably not getting back into the landfill business, and you may lose some of these other services in your community that might be very important. At this point, I'd like to talk about Brown County because I think it is a very interesting story. And the Brown County Solid Waste Department was actually formed back in the early 70s, and it was formed at the request of municipalities within the county. And most of the municipalities at that point in time were incinerating their municipal solid waste, and this is about the point in time when the Clean Air Act and some of the Clean Air Act amendments were being proposed and implemented. So the incinerators were being shut down, and the Brown County Solid Waste Board basically formed as a enterprise fund, which means that no tax dollars are collected for the operation of waste management in Brown County, which is a good thing. And at that point in time, what the county did is constructed 2 sanitary engineered landfills, and these were really the first 2 engineered landfills in the state of Wisconsin back in 75, 76. So that's one of the other interesting things. As we think about waste management, this is still a relatively new emerging field. We're still learning things every day around not only landfilling but recycling, processing, that sort of thing. With the passage of the recycling law in the state of Wisconsin, a dual stream recycling system was implemented by the county in 1992, and that system worked very well for a long period of time. In 1998, we did construct a household hazardous waste facility, which collects well over 1 million pounds of household hazardous waste every year. Again, keeping that from being flushed down the drain and getting to waterways, keeping it out of the landfill. And at this point, that facility now coordinates with Outagamie and Winnebago counties, which are 2 adjoining counties to Brown County, which leads us to the next part of the story. As we started seeing competition from the private sector, the counties essentially realized that one of the best ways for them to remain competitive and stay in the landfill business was to work collaboratively. So they formed what they called the BOA Agreement, Brown, Outagamie, Winnebago, in 2002, and signed a 25-year contract at that point in time to work collaboratively on solid waste services. So from Brown County's standpoint, our landfills basically closed in the early 2000s, which meant that all of the waste from Brown County was ultimately going to get transported to landfills in Outagamie and Winnebago County. So we constructed a transfer station to more efficiently haul that material to those other facilities. Collectively, we constructed a single stream MRF in 2009 and gas to energy at the closed landfills to try and recover some of that valuable methane and use that to produce electricity. And at this point, we're working on extending contracts with the municipalities in our region with the intent that Brown County will be constructing a new landfill in 2018, 2019, at which point in time all of the waste from Outagamie County and Winnebago County will be shipped up to Brown County. So again, you can see with a long-term contract like this, you need to have something very solid that's going to withstand the test of time. It's going to have to withstand changes in political wills, elections, all that sort of stuff, to make sure that everybody's comfortable with this process. At the end of the day, this collaborative has saved a fair amount of money for each of the different counties, so it's been a win-win for everybody. This is a picture of the single-stream recycling facility that was constructed. It was a little over $10 million for the facility. And the facility's been operating very well. You can see that we actually received an award from the Solid Waste Association of North America for the operation of the facility. And I think more than that, it's just the ability of the communities to cooperate and collaborate that was fairly innovative, that also added to the the credibility and the merits of this award. As we work our way down the hierarchy, the next option would be incineration or combustion. And we've had a fairly interesting situation occur in Brown County. We do have a fairly active tribe in the region, the Oneida Tribe of Indians, and they have a business development arm that looks at creating opportunities. And one of the opportunities that they focused on was the construction of a gasification project in Green Bay. The intent was they were going to use about 150 tons per day of municipal solid waste. And if you think it's hard to site a landfill, you should try and site an incinerator. And again, there's a lot of discussion in terms of whether it's an incinerator, a gasifier, pyrolysis. There's some subtle differences between what that means and how the process operates. But from the general public's perception, it is an incinerator, and that's the way it's been portrayed, at least by that group. As we look at this from a county planning perspective, the issue for us was that group was ultimately probably going to go after some of our customers, which would lead to a potential reduction in the amount of solid waste that we had available to contribute to the BOA agreement. And within that contract, if we fell below certain thresholds in terms of tons generated, there were penalties that needed to be paid to make sure that the overall system could maintain the efficiencies. So there were a huge number of discussions, and the thought is if it's not this project, there's going to be other projects like that down the line where we're going to have to deal with these same sort of issues. And we don't necessarily want to be in the landfill business forever. We think some of these other opportunities are great, but understanding this can have a huge impact on long-term planning and solid waste management in general was something that really kind of came to the forefront, and it made us as a region really look at what is our long-term solid waste management plan, out 10, 20, 30 years. Do we want to be incinerating, which is lower, on the hierarchy than recycling? How do we get people to reduce and reuse and recycle so that we don't have to incinerate the stuff in the first place? So those are all big issues that were generated because of the fact that this project is probably going ahead in our region. So the opportunities as I see it, integrated solid waste management is really going to be a big focus in a lot of different areas. And it's a tremendous use of resources. It's a tremendous opportunity to potentially recover some of these resources. So thinking about it in that regard is important. The other thing I would say is, as I noted on the first couple slides, this isn't just a municipal solid waste issue. This is a waste stream issue and a waste shed issue for every community. So looking at this beyond just municipal solid waste is really important. And it's going to become even more important as we need to achieve some of these efficiencies by municipalities. Maybe it's efficiencies by business and industry to remain cost competitive. So all of these things are really going to cause people to start reviewing this stuff in much more detail. Again, it could lead to program changes. It could lead to a lot of different things. It could lead to consolidation. And in some cases, it may lead to program elimination completely. So a couple other examples I want to provide in terms of this integrated approach. And one is a group that we called the Brown County Waste Transformation Initiative. And this was essentially formed because of some water quality issues that we have in the region. And some of those water quality issues are directly waste related. So for those of you not familiar with Green Bay, besides seeing cheese on people's heads at football games, some people refer to us as the dairy donut of Wisconsin because we have about 44% of all the cows in a 7-county region surrounding Brown County. We also have a number of meat packers, rendering facilities, wastewater treatment plants, paper mills, and all of these facilities are generating organic materials that they need to deal with, and the cost of generating and managing those materials has gone up and up over time. So they were looking at some other alternatives. So what ultimately happened is they pulled the group together kind of to focus on what could be done to maybe mitigate some of these environmental impacts associated with the way we're managing materials now. The other thing from a planning perspective is there were some conflicts between urban sprawl, urban expansion, and agriculture and those sorts of things that also proved to be pretty important. Air quality, odor issues, people in the communities, suburbs were worried about groundwater quality issues associated with pathogens and so on from manures. The surface water issue, obviously the nutrients was creating a problem. Fox River is being looked at for TMDL, total maximum daily load, so there's going to be major investments required by the wastewater treatment plants to cut phosphorus, yet most of the phosphorus is coming from non-point pollution based on the data we've seen. So again, really a big management planning exercise. So we thought there'd be better opportunities to manage these materials, so we pulled together a group of stakeholders. And it was a fairly interesting group, and it was essentially led by the Brown County Land Conservation Department. So the thought was initially this is going to be a manure-driven project because that's where a lot of the non-point issues are coming from. Ultimately, we pulled in a couple different sewage districts from Green Bay and Appleton, who again were going to be either the beneficiaries or potentially having to make some strategic investments of some of the activities that occurred. We had two of the meat packers that sat down at the table. These are competitors, so it's kind of rare that you get some competitors trying to work together. Rendering facility, Ag Ventures is a fertilizer company that basically works directly with the farmers. Dane and Jansen owns a quarry, so they need materials for reclamation projects. FECO NCAP, two separate companies. One company, FECO, makes fertilizer equipment for Scots and things like that. So the thought was maybe we could take all this organic material and create a locally generated fertilizer product. And then NCAP potentially might be able to sell that product in some of their existing materials and so on. And then we also have the university and DNR sitting at the table as well. Because of that, ultimately we were able to generate about $250,000 from the stakeholders. We did also get some external grant funding to provide some other ancillary type research needs for the project. And the consensus with this project all along was that there were kind of going to be on-ramps and off-ramps, and not everybody had to be tied to this project forever. And at some point, if the project didn't make sense, people were free to go out and explore their own opportunities. And one example of that was American Foods Group, which basically went out and constructed their own anaerobic digester because they thought that made the most sense to them. And they were really educated on anaerobic digesters and some of these opportunities through sitting at the table with these other folks. Today, they're actually taking waste materials from their competitor and putting it into the same digester. So again, this would have been unheard of 5 years ago, this type of cooperation. The other thing that's happened is the sewage district in town will be doing a major upgrade. And one of the things that they had talked about from a planning process is they do a great job of treating the materials. Because of that, maybe they should be thought of as an economic engine for the community. So if I move into the region, I know that my water and wastewater needs are taken care of. And one of the options that was discussed was, could they take those biosolids, could they compost them, could they put them into other value-added products through some of the local partnerships that were created through this process. So at the end of the day, we had a couple of different projects that were put into the ground, multi-million-dollar projects, and I think from my perspective, one of the more valuable things is that we actually got the different members in the community that were all dealing with the same problem around the table together, and I think the relationships that were developed between those different companies will last for a long time, and I think we'll see a lot of other results come out of the project. Similar to that, Dane County also recently put in a centralized manure digester, and again, it was a water quality issue there as well, where they were looking at phosphorus removal. And in this case, they put together a project where 3 different dairy farms in the Waunakee area all contributed their manure to a centralized digester facility. So this is the first one in Wisconsin. There are a couple other ones. Tillamook up in Oregon had a centralized digester. But again, the opportunity exists here to take the farm manure and also take some wastewaters from some other industries within the region, in this case high-strength wastewater from food processors, and convert that into an energy opportunity. So again, thinking outside the box a little bit in terms of how we look at planning and how we look at dealing with these waste materials. The final thing I would add is, do not forget to look to some local resources that are available. In our case, the University of Wisconsin-Green Bay does a lot of work in this area. We've got both undergraduate and graduate programs that can provide a lot of legwork for these types of projects. And I've got a video clip at the bottom that's about 5 minutes long, basically shows some of the things that have happened collaboratively between UW-Green Bay, FECO, and NCAP in terms of helping them with product development and so on. So that's been a great opportunity to get everybody essentially on the same page and going towards the same goal. So if you have questions for me, my contact information is here. And at this point in time, I'm going to turn it over to Andrew Dane, who may give you more of a planner's perspective on this as opposed to a technology perspective. So.
Okay, hello everyone. My name is Andrew Dane, and I guess before I get started here, I'd like to thank Dr. John for a real nice presentation. I think John does a really good job of summarizing not only the waste management opportunities, recycling opportunities out there, but as he's talking about the different case studies and his work with Barron County, with the Brown County Waste Transformation Initiative and some of his other projects, it really underscores the importance of good planning in a lot of this, and a lot of types of projects that he's involved with. And it's interesting to hear about how he's been able to bring different types of stakeholders together to look at waste from different perspective and identify opportunities where maybe there weren't those opportunities weren't recognized before. So what I thought I would do, give a little bit of background. I think you already got my background. Really, I'm coming at this work most recently. Spent majority of my career doing local planning at the county, at the city and county level, and then more recently with a private consulting firm here, and had the opportunity to do a number of feasibility studies and planning studies for a variety of waste to energy opportunities and renewable energy opportunities over the last couple of years. John and I are currently working doing a pre-feasibility study to look at potential waste energy opportunities for an organics recycling project for a client, and talk a little bit about that in a minute. So the outline of my talk was is probably just going backwards a little bit and drilling down into one of the points around organic waste recycling that John mentioned. I'll try to drill down a little bit on here. Before I get into that, I wanted to sort of just reiterate with this slide. This is from an EPA national level. Almost about a fifth of the waste ending up in landfills being food, and I know in Wisconsin, I believe it's the #1 source of material in landfills. At this national slide, it looks like it's paper. So what are the opportunities there? Why should planners really care about them? Presumably, lots to talk about there. And then what role, if we do care about this stuff, what role can we play as planners in waste management? And then I'll just talk a little bit about a case study with UW-Oshkosh just down the road from us. So in terms of what is it? Talk a little bit about, again, in the context of organics recycling and waste to energy. Biogas is a big opportunity, and Wisconsin has been a leader in terms of on-farm anaerobic digesters. I think we have 30, 35 digesters at this point. And now we're positioning ourselves to be a leader when it comes to the use of dry digesters, which take different types of feedstock, not just wet manure like you'd find from a hog or a cow, but also incorporate other types of drier solids as feedstocks, whether it's food waste, grass, or field crops. Any variety of organic material can be fed into an anaerobic digester, and anaerobic digestion is simply the decomposition of organic matter in the absence of oxygen, and when that happens, you get a couple products, digested solids and biogas, which is mostly methane. And what's interesting about anaerobic digestion here, as you follow the green arrows across, is you can use it not just for combustion, for run it through a genset and create power. You can capture waste heat, use that in the greenhouse. You can also clean that stuff up, and there's been a lot of discussion with this in Wisconsin. You can also clean that methane up, scrub it up to essentially what they call natural gas, and upgrade that to pipeline quality, inject it right into a pipeline, or compress it and use it as a CNG or compressed natural gas. I believe there's a project doing this at a landfill down in Dane County right now, and a lot of discussion around the potential for doing projects like this, utilizing different types of feedstocks, whether it's on a farm or on a landfill, or perhaps in a city utilizing organic waste streams from residential commercial businesses. One of the, of course, interesting things too is when you run this stuff through a digester, you also get solids, and that kind of ties back into some of the comments John was making about the creative use and economic development opportunities, not just from the energy, but also from the byproducts. So there's fertilizer opportunities, animal bedding opportunities, composting opportunities, other value-added products that can come out of a biogas project. Why should planners care about this stuff? I like this little diagram that was kind of a result of some brainstorming that happened in the New York State called Dairyville 2020. I think kind of summarizes, just the full range, just all the different dimensions that come into play when we start thinking about organics recycling and energy production from organic waste, the potential for habitat protection and natural resource improvements, economic development and jobs opportunities, improvements are related to water quality, opportunities to get neighborhoods involved, local youth and folks involved, the connections between this type of work and local and regional food system development when we think about creating local quality soil amendments and other products to use in local regional agriculture. And so, as I look at this and you think about the sort of tie into community sustainability, you start to think, this is almost the perfect storm for planners to get involved in projects like this. Typically, they're too complicated to sort of happen on their own, and oftentimes requires a planner, somebody there, community facilitator, community leader to pull these different stakeholders together. And I love this diagram because it shows the school and the community center, the food processing plant, the neighborhood gardens, the farm stand. I mean, it's got it all right here, this little utopian vision of a sustainable community recycling or all of its organic waste streams. So I think there's plenty of opportunities for planners to get involved, and this slide kind of does a nice job of summarizing that. In terms of what roles planners can play, I think there's a wide range of roles we can play, not just I guess everything from holding forums and getting people together to talk about what some of these opportunities are, doing pre-feasibility studies without the use of a consultant, where you drawing on you take the concept of a waste shed and you start doing some back of the envelope calculations and looking at what are the organic waste streams within your city or your village or your county, and great way to build intergovernmental cooperation and reach out to different stakeholders and start talking about this stuff in the communities. Really, the analysis lends itself really nicely to GIS, which a lot of planners are quite skilled at, and so can be really powerful to take this information and put it in a GIS system and really start quantifying. You'd be amazed how much waste you find out there, waste streams from lots of different sources when you do that. And so there's a lot of educational components. I think there's also a dimension here in terms of just helping community leaders and communities understand what the opportunities are, assess the opportunities, and promote the opportunities if you're coming at this more from an economic development job standpoint. And then lastly, the more typical role, of course, is managing and regulating these types of projects that often have certainly do have a land use component, transportation components. They've got impacts, and so planners obviously play a role there as well. This screen capture I have here was a project I was working on when I was with the university, and then into my current job with SEH, putting together a guidebook on how to facilitate community participation in renewable energy. And there's a URL down there if folks wanted to take a look at this resource. In it, we talk about wind, a whole range of different renewable energy technologies, including anaerobic digestion, and I thought I would just kind of share this with you. It has, in this toolkit, we put together a series of matrices that can help, I think can be of value for planners, community development folks to start working with communities and thinking about sort of the range of issues associated with energy projects, and in particular anaerobic digestion or biogas or organics recycling projects. You can use these as checklists, looking at environmental impacts, looking at different scenarios. You can tweak these things and come up with your own scenario. It just helps people understand sort of what are the environmental, what are the economic dimensions to projects like this. Oftentimes when you're on the cutting edge or bleeding edge of these types of projects, they're public-private projects, and they involve a significant amount of public investment. And you certainly want to get people on board with a project like this and understanding full range of the economics and what are the ups, what are the costs, what are the benefits going into projects like these. And then they can also be used to think about the social dimensions of these sorts of projects and how it impacts communities and people and organizations. And so this is a nice little tool, I think, to maybe think about doing some strategic planning, whether you're bringing stakeholders together to do community visioning around waste and recycling, as along the lines of John's example from the Brown County Waste Transformation Initiative, whether you're looking at this from a job standpoint. These matrices can be helpful in terms of having those discussions. Ultimately, I think it's about building partnerships and doing a lot of community planning activities to sort of identify where these types of opportunities lay and how to move them forward. One of the interesting case studies we have just down the road here in Oshkosh, Wisconsin, is a brand new project. It's a dry digester, meaning it uses relatively dry feedstocks to create biogas. And it just started up a few months ago, started running. That's the first system of its kind in North America, or perhaps in the Western Hemisphere, if I recall correctly. Not particularly complex. They've got a number of these already up and running across Europe and Asia. But it's a real, I think it provides a nice kind of look at probably the future of organic waste recycling in around the world. As we start looking at organics waste streams more as an asset and less as something to fill up our landfills. And John and I visited this site recently, and the system they have down here is a biofirm system, and you can kind of see, just looking at the diagram there, the basic the biomass comes in, and in this case they use a range of different types of feedstocks. They're using some grass clippings. I believe they're using a lot of commercial, residential food waste. I think they've used a little bit of manure to actually get this thing up and running, some extra yard waste. So using a variety of organic feedstocks that sort of come in the door. The stuff gets put into one of 4 different vessels or chambers where it sits for, I think it was roughly well, I'll get into the details, I guess, as I move along the slide here. This provides kind of a nice schematic, and what's interesting is that you can see where the organic feedstocks sit and decompose down below, and then that bladder bag, number 4, is where the gas ultimately vents up into the ceiling and into that bag. That bag then, the gas is then conveyed over to 5 and 6, which is a combined heat and power unit, skid-mounted system. European technology creates power and heat. So yeah, getting into some of the details here with the feedstocks. I'm just going to talk about this project a little bit of detail, not so much the planning component, but kind of give you a sense of what's a fairly innovative project here. This system's designed to use between 8,000 and 10,000 tons per year of feedstock. The campus, interestingly enough, only produces about 500 tons of waste. So you can see even a big facility like this, needs to be thinking more regionally in terms of its feedstock base. There's simply, even at the school, they're simply not generating enough waste to keep something like this going. Right now, they're having a contract with waste haulers that are providing. One of the waste haulers they're contracting with is a large nonprofit that distributes foods, leftover food to food banks and food shelters around the state, and occasionally when they've got excess product, they can now truck it in here, and they've got a place to put it rather than go into a landfill. But their ultimate goal is to get this thing to source all the materials from within a 30-mile radius as the project moves forward. The technology is really simple. They're just 4, as I mentioned, 4 fermenter bays, I guess is what they call them, each about, long enough to put a few semis in, 23.5 feet by 16 foot deep by 70. And it's fairly low tech. The material, there's a front end loader that takes the material and drives it in there. And stuff sits in there for about a month, and then after a month, about half of it's taken out, and then half of it's taken out as compost, and then the other half is put back in there and mixed in with the next batch of fresh organic waste. And so you end up kind of in a continuous process of pulling out compost and injecting new materials in there. All the while you've got, you're producing gas and power. They do keep it well heated with the glycol heating system within the walls and floors of each of the digester bays to stimulate digestion. And then, as I mentioned before, the gas actually vents up and it's collected in this rubberized diaphragm that sits on top of the four different chambers there. They have a 370 kilowatt CHP combustion engine just located right outside the facility, and you can sort of see the scale of that thing. Not huge. And so as these types of projects move forward, oftentimes it's good if you can locate these things with another entity that could use that waste heat, because there's typically waste heat that's produced from these sorts of projects. In terms of the markets for the stuff, they're selling the power back to the grid. They calculate when they finally get this thing up and running at full capacity, they'll actually provide about 10% of the university's total energy, so fairly significant. It's currently running at about half capacity now as they are kind of working up towards optimizing the technology. It doesn't create a ton of jobs. I think but they do have a few. I think at least one full-time staff person there, and then several part-time folks, including some students and professors. Does require regular monitoring and testing, but they've got it situated in such a way that can be remotely operated through a web-based platform. You can see down there at the front loader, right in front of a pile of compost that just came out of one of the vessels. I'm going to close with just a little discussion about some of the opportunities and challenges with organics recycling, and the notes on here is specifically related to the Oshkosh project and probably a little not as relevant to the broader discussion. In terms of some of the opportunities here with organics recycling and waste energy opportunities is, the big one, of course, is keeping keep extending the life of landfills by pulling this material out of the landfills, keeping yard waste and other types and manure and other organic feedstocks out of waterways and out of oftentimes you end, as folks know, you end up with leaves and other yard waste running into waterways, and which can cause eutrophication of lakes and rivers. So if you can pull this stuff out, where there's excess organic material, there's an opportunity to realize some environmental improvements. And then also in terms of neighborhood scale, there's also, I think, an interesting opportunity when you think about doing these projects more at the neighborhood scale or at the district scale, as we're thinking about neighborhood and district scale community sustainability and the opportunity to do organics recycling with or without energy production. But when you tie that back to kind of the flourishing market for local community gardens, a lot of communities are having a lot of success with, and you start tying in the program where you're getting kids and youth and volunteers involved in collecting organic food waste from area businesses and restaurants and utilizing that in community gardens, and you start tying the stuff together at the neighborhood and district scale, and I think it makes a lot of sense and some great opportunities. There's some interesting work being done along this lines down in Milwaukee with a nonprofit called Compost Kids. That's 2 Ks, Compost Kids, if you want to look that up, where they're doing just that. They're integrating sort of local neighborhood scale food waste recycling with community gardens. In terms of some of the challenges for these types of projects, one of them I think would certainly odors and siting issues and any type of land use issues you might have, but probably even bigger than that would be, how cost effective is it really to collect residential organic waste, for example? Is it really pencil out to collect this stuff with trucks running around neighborhoods collecting small amounts of organic waste. And should we be encouraging it in the first place, or should we be encouraging folks to just take their stuff out to the backyard and throw it in a compost pile? So those are some of the, I think, the challenges associated with these types of projects. And so it's not just a panacea. I certainly don't want to present that view of it. But there's certainly opportunities as well where there's sufficient waste streams available, but it's not without its challenges. I guess in conclusion, I'll just sort of wrap this thing up, and then I think both John and I are available to handle any questions that might be out there. John's pacing behind me. He's ready to answer a few questions. So in conclusion, there certainly are organic waste energy opportunities out there, and they seem as if they're poised to grow, not just at the sort of individual farm scale, but at the multiple farm scale and community scale as we start thinking about food processing and wastewater treatment plants and institutional waste, restaurant waste, hospital waste. So there's a whole wide range of opportunities out there. A lot of communities and a lot of businesses are moving forward with these types of projects, assessing them. And of course, all these projects are closely tied to the things that planners do in terms of job creation, natural resource protection, land use, transportation. So I think planners can play a key role facilitating these types of projects and getting involved in these types of projects in any number of ways. And so I think with that, I'm going to see if Brittany's still on the line. If folks have questions, we're here.
Okay, thanks Andrew and John. Our first question comes in from Sue Fox. I think this goes back to John early in the presentation. Could you explain the tipping fee?
Okay, I believe there's a question on the tipping fee.
Yeah.
And really what that is essentially how much it costs to dispose of a ton of waste. And when I think of the tipping fee, there's a number of different components that go into that. And one is just the siting of the landfill itself. You have to purchase the land, you have to do all the engineering, you have to do community meetings, that sort of thing. So there's a number of upfront costs before you ever put a ton of garbage into a landfill. And again, that's one of the major reasons why if a municipality goes out of the landfill business, there's a huge startup cost to get back in business. So that's a challenge. There's also cost in the tipping fee that's associated with the operation of the landfill. So as you're compacting, as you're putting daily cover, all of those sorts of things, the personnel. And then the final component of that is you'll basically have to cover the landfill when it's full. So there'll be final closure. And then you also have to maintain that site for a number of years beyond that, which is called post-closure care. So you have to also build all those costs into the tipping fee as well. And then again, some communities have small fees that are attached to the landfill to provide for household hazardous waste, some of these other educational services and so on. So historically, landfill tipping fees in Wisconsin have been relatively low by comparison to East Coast, West Coast. Again, because of that, we brought in a tremendous amount of waste that came across state lines from Minnesota and Illinois. About 3 million tons was where it peaked out, and now, given that we had some legislation to increase our tipping fee by about $7, that amount has dropped almost in half, and actually more than half. So, that's been an interesting dynamic.
Okay, John, I think this question will also go to you. This question comes in from Andrea Aldrich. How do you quantify the economies of scale? Do you have good example models?
Again, I would look at economies of scale from different perspectives of the whole waste management system. So in some regards, a landfill, there's clearly economies of scale in terms of a landfill as you look at how many pieces of equipment you need to move waste around, that sort of thing. So there might be economies of scale that would exist at a bunch of different levels within the waste management collection, processing, disposal. So there are some examples out there of that. And one of the cool things that's going on right now is I did actually get a grant to go in and look at what's going on and what has gone on in the last 4 years in Wisconsin with the responsible units. to look at ways for us to identify some efficiencies within that system. So it's really a chance for me to have a redo of my master's thesis, which not too many people get the opportunity to do. So we're hoping to have some good information on that in terms of which responsible units are more efficient, which ones are not. And one of the problems with that is the difficulty of identifying what are the metrics that you're going to measure efficiency by. So one of the metrics could be, I want to collect as much recyclable materials as I possibly can. So if that's the metric, that's going to be different than I want to collect it at the lowest cost per ton possible. So I guess as you're looking at these economies of scale, the same sorts of questions come into play. What is the ultimate goal of your overall process? Is it to divert as much material from the landfill as possible? Is it to collect it most cost effectively? So there's a number of different ways to think about that question, I guess.
Okay, our next question comes in from Douglas Martin. How much of an adverse impact could continued inappropriate waste disposal have on climate change in the long term? What impact does the incineration of mass waste have on depletion of the ozone layer?
Okay. Again, most landfills now, there's EPA requirements that if the landfills are of a certain size, that they do have to manage the biogas that's produced. So the minimum requirement would be that they would flare that biogas and basically burn it off to destroy the methane. Most of the bigger landfills, again, are now constructing gas-to-energy projects to basically utilize that as a resource. So that's a good move in the right direction. But again, one of the problems with landfills is it takes years and years and years and years for that waste to break down, anaerobically. As Andrew talked about the Oshkosh project, that degradation essentially occurs over a 28 to 31 day period. So you can accelerate what's going on in the landfill and more economically extract that resource. In terms of combusting or gasifying waste, again, it's a matter of, I teach an industrial pollution control course, and I always tell my students that, one of the interesting things about pollution is that you can essentially pick whichever media you want to contaminate. So I can throw it in a landfill, leave it as a solid waste with the understanding that at some point that landfill is ultimately going to leak, and then you may have a groundwater problem. I can combust that waste in an incinerator or gasifier, and I can create an air pollution control problem. If I don't do a good job of source separating the material before I put it into the combustor, I may be producing hazardous waste from computers, electronics, or all those sorts of things. So there's no perfect solution, I guess, is the problem. And again, that's what creates the fun in my mind of looking at all these different things and trying to come up with the most optimal solution with the understanding that it's still not going to be perfect from an environmental standpoint.
Okay, our next question comes in from Sandra Day. How large does a farm need to be to support an anaerobic digester?
I can comment on this one too. I've also done a lot of work with a program in the state called Focus on Energy, which was pretty instrumental in funding a lot of the farm digester projects in the state. So at this point, Andrew was correct in that the state of Wisconsin leads the United States in the number of installed systems. And the general rule of thumb that we've used is somewhere on the order of 1,000 cows is necessary to do that. There's a really good casebook out there of every single anaerobic digester in the state of Wisconsin that was done by an individual by the name of Joe Kramer, and that can be accessed through the Focus on Energy website. It's the Wisconsin Biogas Casebook, and that will give you some real good numbers in terms of the energy produced for each of these systems, how many cows they have, what the project economics are. And there's been a number of different iterations of these casebooks. So this is the third version that's out there right now. In saying that Wisconsin leads the nation with 30 digesters, I always like to point to Germany, and been involved in a couple recent meetings with some folks from there, and they have on the order of 7,000 digesters in an area roughly the same size as Wisconsin. Their population is about 4 times as large as ours, but they've got some different policies in place that essentially promote digesters a bit more. But so that's a long answer to a short question. 1,000 cows. There are a bunch of people around here working on trying to create opportunities for smaller farms But again, from an economies of scale standpoint, the problem is if I'm going to produce electricity and put that electricity to the grid, I still need switchgear, I still need all that equipment, and that's a fixed cost essentially. Whether I've got 20 cows, 200 cows, 2,000 cows, or the biggest farm in the state we have now is about 8,000 cows.
Okay, our next question comes in from Angel Arroyo Rodriguez. Dr. John, could you talk more about the BOW agreement? Are there others like it happening now? Are all RUs within the counties controlled?
That's an interesting question. So the BOW agreement was really the first one, and I had a couple of my graduate students that did some research on that project and tried to find other similar things across the country. We really didn't find very much for solid waste, but we did find others that had consolidated firefighting and police services and those sorts of things. And I think we're seeing more movement in, at least in Wisconsin, in that direction here as well. So that's been interesting. As I look at Brown County and Outagamie County, those two counties are set up entirely different. So Outagamie County is the responsible unit for recycling. And Brown County, we have about 30 responsible units that actually bring materials to Brown County. So even within this BOW agreement, there's two completely different sets of organizational structures in place. And again, some of it comes down to what local control people want and how much they want to cede to the county and that sort of thing. So there is no perfect answer within the system. Both of them function very effectively, but it's done completely different 20 miles apart. So.
Okay, our next question comes in from Mark Freeman. How can we use the plan review and local development process to encourage some of the great concepts discussed?
Okay, I'll turn that one over to Andrew. So.
Okay, what the question was, how do we use the plan review process to implement some of the things we've discussed?
Yeah.
Yeah, I haven't been, to be honest with you, I've been more kind of on the developer side of this, looking at these opportunities for kind of more on the feasibility side, and more on the economics. But I think, in terms of preparing for these types of projects and facilitating them, I guess one of the things I would do is try to do, looking at the local regs that are in place, do some type of gap analysis and try to get ahead of projects like this and identify what might be some relevant land use issues, permitting issues that might be associated with these types of projects. I think Oshkosh being the first one in the Western Hemisphere, I don't suspect there's going to be a lot of precedent for these types of projects in terms of what's out there ordinance-wise. So not a very good answer to the question, but that's about all I got.
Okay, well, our next question comes in from James Lyson. What model of ownership do you recommend for landfills if municipalities no longer will own and run them? For reference, the state of Maine no longer permits commercial landfills.
Okay, I'm going to turn that one to John.
Okay, so the question's related to ownership of landfills. Again, most of the landfills at this point in the state of Wisconsin are privately owned. So it used to be about 85% municipal, 15% private. And because of some of the regulations that were put in place requiring engineered landfill design, that essentially pushed landfills to be bigger and bigger. So now it's completely flipped in Wisconsin, where it's about 85% privately owned and 15% municipally owned. So again, in the case of Brown County, the county is the person that's responsible for the management, long-term care of that particular facility. That same thing would be, whether it's a waste management or Veolia or whoever owns the landfill, they're essentially responsible for it, for that post-closure care. I haven't seen too many other creative ownership models at this point in time. So with the Brown County scenario, we essentially had a landfill in each county. So Outagamie maintained control of their landfill, Winnebago maintained control of their landfill, Brown County's got our 2 closed landfills, and then we will ultimately, maintain control of the new landfill that we will be constructing in 2018, 2019.
Okay, our next question comes in from Christopher Lloyd. Can you discuss the permits required for the digester facility?
The Oshkosh project, or are we able to get at which digester project?
I'm not sure.
Okay. So for farm projects, essentially, there's some rules for farm projects, and there is in Wisconsin anyway. So there is some ability to take in off-site materials. If that number, it used to be 10%. If the amount was more than 10%, then it was effectively regulated as a wastewater treatment plant. If it's not above that, then it's regulated differently, as more of a manure management facility. From some of these other facilities, again, you're going to have to go through, because you've got engines there, most of those will be under the de minimis in terms of requiring permitting, that sort of thing. So there's not as much permitting, and one of the concerns I have with farm digesters is, in some regards, there's not as much professional engineering that's done on those projects, or at least, when this first started up for the early 2000s in Wisconsin, there was not as much engineering, and it wouldn't be designed the same way a wastewater treatment plant would, in some ways, to save money. And so my concern is, if there's one accident, at one of these farm digesters, that could really have some negative connotations for the overall industry as we're starting to ramp this back up. But so from a regulatory standpoint, there's much less on farm digesters than what there would be for a municipal wastewater treatment plant in terms of construction requirements, regulations, and so on.
Okay, great. Our next question comes in from Janelle Flagg. Can other animal waste be used in the system?
Yeah, absolutely. So Andrew mentioned, I think, a hog manure project that's being considered. And then there was actually a project down in southeast Wisconsin where they were looking at duck manure, I believe. So the way animals are talked about from a regulatory standpoint, they look at animal units. And one animal unit is equivalent to 1,000, used to be 1,000 pounds of live weight, essentially. So typical dairy cow is about 1,400 to 1,600 pounds, or 1.4 to 1.6 animal units. If you cross over 1,000 animal units, then you start being regulated more strictly in terms of land application of manures and that sort of thing. So you need far more ducks to get an animal unit than you do need cows. The interesting thing with that project is they were marketing the solids as Father Dom's Duck Dew, I believe was the name. And for those of you that have ever eaten Paul Newman's salad dressing, they used the same marketing firm to create the Father Dom's Duck Dew packaging, and it looked remarkably similar to the salad dressing. So.
Okay, our next question comes in from Tom Wiggins. How supportive are public utility providers to partnering with alternative energy generation sites, e.g. digesters, methane gas from landfills, etc., from a political, financial, and cooperative perspective?
That's been a tremendous challenge. The interconnection agreements do raise some issues, and then the buyback that the utilities are willing to pay for the electricity has been the other big issue. So speaking for the Brown County landfill project, we ultimately got a blended rate of about 7.3 cents per kilowatt hour, I believe. So that accounted for some of the off-peak power, some of the on-peak power. And that also included all the environmental credits that went along with the project. So some of the farm digesters, at least a few years back, were making a fair amount of money off greenhouse gas credits that people were acquiring. Given what's happened, that's kind of dried up a little bit. But working with the utilities can be a challenge. Some of the utilities do have renewable portfolio requirements, so that would provide more of an incentive for them. Most of the utilities in our state have been able to meet some of those requirements through some large wind projects and that. So at that point, they're not willing to, pay a huge premium to get this power from these types of projects. My argument is always that landfill projects and, biogas projects from farms and so on, that power is more valuable than the power that's produced from a wind turbine or a solar panel, because it is dispatchable and it's available essentially 24/7, where the wind and the solar power are not. But that's still a tough argument to make with the utility. So it has been a challenge. We have a fairly strong group here, which has consisted of folks from Focus on Energy and a number of different stakeholders that have been trying to get a statewide, tariff or a statewide rate for all biogas. But that to this point, that has not happened. So.
Okay. Our next question comes in from Marlene Leons. Dr. Caters, is there a copy of your master's thesis online? If not, where can one be obtained?
Unfortunately, there is not a copy online, but you can probably go to the UW Green Bay Library and get it through interlibrary loan, or I might be able to have somebody scan it in, and if you can just drop me an email, I can probably do that. It was almost painful to have to go back and read my own thesis, so. But yeah, I can certainly make that available to folks.
Great. Our next question comes in from Brian Freeman. Do any of your examples include concrete crushing? If so, what type of off-site impacts are associated?
I have not been involved in any of those types of operations. That wasn't really one of my materials when I worked for Recycling Market Development Board. But I know that is pretty prevalent these days in Wisconsin. And let me just check with Andrew here. Anything about concrete crushing? No. Yeah, unfortunately, we can't help you on that one.
Okay, our next question comes in from James Pona. Can you explain or clarify what you mean by feedstock?
Yeah, again, as I'm looking at different projects, when I use the term feedstock, I'm looking at that essentially as a resource or a raw material that could go into a project. So for a digester like at Oshkosh, there would be a number of different materials that could go into there, as Andrew described. It could be food waste. It could be other organics derived from food processors and so on. So I use that term fairly generically to talk about anything that might at this point be a waste that could potentially become a resource that could go into a project.
Okay.
So as I'm looking at the waste shed model that I talked about, which is one of the things that we did, in Brown County to try and identify who the stakeholders would be, there's a lot of publicly available information in terms of the amount of waste that people are disposing of or generating. Otherwise, you can use some standard industry numbers and create that table essentially to figure out what is being locally generated within your community and what those feedstocks, what those potential resources might be.
Great. Our next question comes in from Andrea Aldrich. Are there solar panels on top of the biofarm?
No, there are not.
Okay.
So basically you have the roof system, there's a gas bag that's right underneath the roof, but there are not solar panels on top. But there certainly could be because you'd have all the interconnection equipment right there to allow that to happen. I would add that at the University of Wisconsin-Green Bay we do have our largest academic building, which has two different photovoltaic arrays on it. So on one of our roofs, between a standing metal seam roof, we have a thin film PV system. And then we also have another system that's in an atrium area where we have what's called a vision glass. And the vision glass, they actually put the PV material on, and then they use a laser to essentially etch off some of it to allow some of the light transmissivity to go through to create a nice viewing area. So that's the first building anywhere in the country that has those two systems combined on it. We get a lot of architects and engineers that take tours up through that facility to see that. So.
Great. Our next question comes in from Kevin Burns, and I think it'll be our last question for the day. Does Wisconsin still have a recycling market development board? Virginia abolished its own last year.
Yeah, ours was abolished in about 2000, and that was right about the time I went from working for the market development board to taking a faculty job. And I did just have one of my graduate students do a project going back and looking at all the projects that were funded by the Recycling Market Development Board over the course of about 8 years. And you'd be surprised there's a large number of those companies that are still in business and have expanded their use of recycled materials. And again, one of the reasons I wanted to do that study was to demonstrate that there were some really cool things that came out of the work that was done at that time period. We've essentially turned our back on it now by eliminating all those programs. So again, the two that I cited when I talked, one is a company called Cascade Asset Management. They were able to get some development funds to basically put the business plan together. They got some money to do some R&D work from Wisconsin Department of Natural Resources, and then we got them some startup money from RMDB. They're one of the, again, largest computer electronics recycling companies in Wisconsin. And then NCAP was another example where we got them some money to basically do a business plan, which followed a grant from the DNR. To do some of the research and development on their products. So there were a lot of companies that worked their way through the system the way it should be done. Let's essentially do some research, come up with an idea, put a business plan together. The business looks viable. Let's go get a low-interest loan, build a facility, and start to make product and create jobs. And again, you'd be hard-pressed to find any of those resources these days in the state of Wisconsin to allow a company to do the same thing that those companies did back in the 90s.
Okay, great. Well, thank you so much, both of you, for giving this presentation. And if anybody has any follow-up questions, Andrew and John's email addresses are listed right up on the PowerPoint right now, so you can jot those down and contact them later. So for those of you who are still with us, I'm going to go through a few reminders in just a few minutes. Thank you again, Andrew and John, for presenting today.
Thanks for having us.
All right. Well, for those of you who are still with us, I'm going to go through a few reminders about how to log your CM credits for attending today's webcast. Go to www.planning.org/CM, select activities by date, select today's date, which is Friday, February 10th, and then select today's webcast, which is Planning for Innovation in Waste Management and Recycling. This webcast is available for 1.5 CM credits. Also, we are recording today's webcast, and you will be able to find a recording of this webcast along with a PDF of the presentation at www.utah-apa.org/webcast-archive. This will be available early next week, and this does conclude today's session, and I want to thank everyone again for attending.
Wow.